Hi, welcome to Teardown Tuesday. Yes, it's retro multimeter time. Check this puppy out. It's a Digimer 10 from a company called Iskra, and it's actually a Yugoslavian made multimeter. I mean, you know, real retro. It's not a modern design. Check out those 4mm banana socket inputs there. Really ancient, but obviously some sort of LED display in there, and we've got the manual for it. It was sent by Sylvain. He's an EEVblog viewer. Hi Sylvain, thank you very much. Sent it into the mailbag segment, and we saw that on there, and it's even got some tips for using this sucker on the back. There it is, and it's in really quite good nick. And we have the full schematic, which I'll link in down below, which is in the back of this. Look at this. Got the original manual for it and the fold out schematic. Fantastic. So I'll scan that in and that will be linked down below. Actually, the circuits are rather fascinating and worth a look. I mean, check out the power supply down here. Look at this. We have a discrete switch-in power supply. It's even got the switching waveforms down in here. For example, what do we got? TP 2.1. There it is. +5, we've got a multi-vibrator, a classic 2-transistor multi-vibrator circuit here, and that allows it to generate the required supply voltages for this thing. Really quite neat. Our display driver up here, look at what we've got. We've got an MC 4511 7-segment driver. Absolute classic, and it really LD 111. Looks like one of them. Looks like the main device down here. There's an LD 110 and an LD 111. So it looks like it's a 2-chipset multimeter. Haven't seen these ones before. I'm going to have to Google that. See if we can get anything on there. And once again, we've got more waveforms down here. I like it. We've got some op-amp action down here. Lots of quite a few trim pots in this thing, I think I can see. We've got one there, one there. We've got a discrete JFET input there by the looks of it. And here's our input. Yeah, here it is over here. Volts and ohms going in. We've got some, compensated 10 meg resistor there. We've got ourselves another trim pot down there. Another trim pot. Trim pots absolutely all over the place. And this is rather unusual down here. Look, these are resistors, but they've actually, look how they've actually drawn them here, like they're inductors or something like that. I don't know, really weird. Is that common in Yugoslavia? I don't know. Any viewers out there, please let us know. But that's our current input there. There are different range switching. I'm going to assume that that means these are wire wound resistors, so it wouldn't surprise me at all if we open these up and found wire wound resistors in there. But why you'd use like a 9K wire wound resistor up here, I just don't know. But you know, it'd make sense for the lower current shunt ranges, of course. It's got really nice. It goes down to 20 microamps full scale. Check that out. Really quite neat. So it's rather quite a usable meter. I mean, anything that goes from 20 microamps full scale up to 2 amps is going to be is a pretty useful multimeter. 200 milliamps. It's got AC and DC. I'm assuming, of course, it's not true RMS. It's just going to be average responding there. And yeah, that is quite neat. Goes up to 20 meg, 200 ohm minimum scale, but quite a usable meter for its day. And you guessed it, it's got a 555 timer. Beauty. And check out this legend down here. Here are the different types of resistor symbols that they're using in this. If you've been wondering why they look a bit weird ass, then look, these are carbon film, metal film, power resistor. Haven't seen that before, using different ohm symbols like that. Once again, is this a Yugoslavian thing? I have no idea. So yes, obviously, it needs plus minus 12 volt rails here to power the main chip set over here. So those ones operate, there we go, plus and minus 12. Where's plus? There it is, up there. And if we have a look at some of the specs here, there we go. It's rated for operation at 23 degrees C, Operating temperature 0 to 55, storage temp, frequency range for the AC, of course, 30 Hz to 20 kHz. Once again, assuming average responding, powered from 4 NiCad batteries. There you go. Recharge time 16 hours. Doesn't tell you what the consumption of this sucker is. It might up here. Anyway, standard 10 meg input impedance. They even specify the capacitance there. 3 readings per second. Not bad at all. Settling time 1 second max for all DC ranges. So it looks like it might have a bit of a settling issue there. And maximum potential on the ohms V connector with open sockets plus minus 14 volts. And there's our measurement ranges. Goes up to an impressive 2000 volts DC. Yeah, that's very rare to find that. The only ones I've seen above 1000 volts are an old triplet analog meter I've got here, which I think goes up to 6000 volts or something like that. But yeah, very handy. I mean, 20 microamps full scale, the maximum reading. It can actually go over range just a little bit. But have a look down here. It's actually quite impressive. 0.2% of reading and 0.1% full scale. And it specifies the temp co in terms of per 10 degrees Kelvin. Look at that, instead of per degrees C. But that's pretty good, even on DC current, 0.2. Not bad at all. I like it. 0.2% for ohms. This was pretty good for its day. And there's our block diagram. Nothing really special, of course. Got the input attenuator and the ohms to voltage converter for the ohms range, your current shunts, and then it's got the 555 timer. In there was obviously operating the analog to digital converter there with the voltage reference. I didn't have a look at voltage reference, and then we've just got a basic BCD to 7-segment decoder to drive the LED display and the converter in there, and a AC to DC average responding converter. So let's crack this puppy open, and we have some sort of little key lock here on the side. I'm not sure what that does. Does that just... no? What is that? Whoop. Oh, there we go. Oh, that's our fuse. There we go. Oh, beauty. I like that. There's our fuse. We'll put that back in. There we go. It looks like probably these 4 feet on the back here. Do they? Yep, they pop out. Oh, hang on. What's that? We've got ourselves... I don't know what that is. Oh, it's one of those, yeah, I don't know the name for those, actually, but I might have one of those in my kit. Yeah, there we go. I've got one of those little 2-pronged ones. The name escapes me at the moment. Everyone's probably screaming at their camera, going, oh, I know what that is. And, yeah, well, okay, no, I need a bigger one. Aha, I found a date code. Look at that, 7th month. I assume it's a date code, 7th month, 1980. Yeah, that'd be about the vintage that that's probably what I guessed. Would have guessed, late 70s, very early 80s at the outside. So, woo, 33 years old, folks. That's probably older than the age of my average audience. So yes, this will be rather interesting. I mean, it's going to be all through hole, of course. Surface mount wouldn't have made its way into something like this back then, so I expect, I don't know the quality of the construction. I have no idea about this brand. Never even heard of it before, and but we'll have a look for a 33-year-old technology anyway, all through hole. Probably no solder mask on the board or anything like that. It'll be, I think that's done enough, and it'll just be like maybe a tinned board, PCB or something like that. We'll see how I'm not sure how probably 2-board construction maybe for the LCD, something like that perhaps. Anyway, it should be fascinating, and don't expect cat input rating on this thing and huge input protection and isolation slots and all that sort of stuff. No, they didn't care about that sort of stuff back then. Heck, even the flukes really weren't. Whoop, better not lose those. Hang on, better chase it. Right, here we go. Got them out. And I wonder if the batteries are still in here. No, they're not. There we go. Ta-da! There we go. There's our 4 NiCads. I assume it would work off alkalines as well. Check it out though. This is chock full of retro goodness. We've got ourselves a little shield on the top there. Twang! Got a couple of adjustment, what looks like adjustment caps there. Probably for the AC performance there. And what have we got down here? Looks like that's weird. It looks like maybe some sort of something, one of the wire wound resistors. Yeah, there's a monster inductor or wire wound resistor there. Not sure what's going on there, but yeah, basically 2-board construction. It looks like the Note 3 with the LCD. LCD. Oh, sacrilege. Wash my mouth out. LED down in there. We'll take a look at this. Actually could be real tricky to take apart. I've got to get all these off, and then these have to lift out, and then the top board, who knows what the range switch does. Anyway, check out here, there's our battery compartment for our 4 IEC KR23/43 NiCad batteries. And there we go. If we have a look at the board down there, it looks like it is gold plated down there, hand drawn PCB. That looks like it's done with good old Dello pen or something like that. By the way, it got the original plug pack for it as well. Sylvain sent that in, and there it is. It's even an Iskra branded plug pack. Check it out. Fantastic. Oh man, that does smell as old as it looks, folks. Oh, that old electronic smell. So we'll whip this shield off here, and hopefully we can just peel it off layer by layer, because I haven't powered this thing up yet. I don't even know if it works. Sylvain didn't mention whether it works or not. Whoops. There we go. And, oh, way, look at the range switch. Oh, this is a beauty, folks. Check this out. Have you ever seen such a sort of, sort of slapped together Heath Robinson-ish type contraption range switch? Oh my goodness, that is just really something. Look at those contacts in there. And it's sort of, we've got these wires just bodged across the board going down there. We've got these wires going down here. Big beefy things. I must be carrying the range, the current. Anyway, let's see. Here we go. It's about to pop up, so we'll be able to see this contact here now pop into place. Ready? There we go. So that one just, oh man, that is really something. Look at that. Wow. That is bodgy, brothers. But actually, the more I look at that, the more I think, well, that's that is actually rather clever. I mean, it looks all bodged together up the top here, of course, but the actual arrangement itself there isn't that bad. Let's see if we can switch this here. Look at that. Look at that. That's actually just really quite nice. The more I look at that, the more I think, yeah, that's really rather clever. Look at that. Somebody had fun anyway designing that. And we have all gold-plated tracking there, of course. Very reminiscent of, say, the early HP gear and stuff like that. That's, you don't see that anymore. You can't just, piss away the gold these days with gold prices the way they are. But of course, all of that is hand taped, of course, back on the old, days of the light boxes and stuff like that, when you put in the curly traces and everything else. Beautiful. You don't see that anymore these days. Because the nature of how these boards are wired together like this. They've got the wires going down between the two boards like that, and then wires, and then cables snaking over the top like that, and they got the same. Love this ribbon, pink ribbon. First teardown that contains a pink ribbon. Make of that what you will. And of course they've wired these boards together like that, so it's really not designed to come apart, and I'm really quite hesitant to take those boards off, but I'll take these nuts off and see if the entire sort of assembly lifts out. But yeah, I really don't want to go, because I haven't powered this thing up. I really want to see what it's like. But yeah, oh man, it's like, I really don't want to ruin the sucker. There's the other, no, what's that? I thought that was a switch. No, that's like some big ass inductor down in there. Monster. But yeah, this is probably one of the most difficult multimeter teardowns I've ever done, because it's just, wow, so hand built and just, man, not designed to be mass assembled. Designed for manufacture? What's that? Just build it and ship. And in there you can see your traditional PCB mount range switch with the like a wafer type switch there, contact switch going between the etched gold plated things on there, and it looks in really good nick actually, so I'd be surprised if this thing doesn't work anymore, and it's you know, probably still within spec. So before I actually attempt to take this apart, I will actually power it up. So I've got external 5-volt supply there hooked onto the battery, so hopefully let's give it a go, shall we? Let's put it, is that the voltage of the battery, I guess? Let's turn it on. Hey, there we go. Yep, there you go. It works. 5.07. Well, my power supply is showing 5.00, but I could measure that with a multimeter and see which one's more precise. No, there you go. It's a little bit out reading the battery. Ah, well, you can't have everything, but there you go. It seems to be working a treat at the very least. Awesome. And what do you know? I've got that hooked up to my calibration, lab calibration standard here, set to bang on 2 volts. In fact, 2.00000 volts, and we're getting 1.997. That's within spec. And by the way, if you want to know the current draw, just over 200 milliamps there. So there you go. That is fantastic. Ah, it's a thing of beauty. Joy forever. Let's overload it. Oh, flash in, warn in, Will Robinson, warn in. Let's measure my resistance standard here. It's like 0.005%, good enough to measure this puppy. And it's really good. These are dual adjustments. I haven't used a multimeter like this in a long time. And you move it around here, it's annoying. It doesn't work at all. You've got to actually switch it over to ohms, and we're bang on. We are bang on, folks. Not a problem whatsoever. Awesome. This thing, 33 years old. Oh, can't beat Yugoslavian technology. There you go. 1K. Let's switch it down. There we go. That's pretty good. That's pretty good. I'll give that a win. And if you put the leads open, there we go. It just goes full scale and just flashes at you. And of course, no continuity buzzer. And there's something, it seems to be something wrong with the current range here. I've got it on 200 microamps there, and it's flashing its digits at me. And shouldn't be doing that, because I'm only feeding 10 microamps there. So really, I don't know what the deal is there at all. And well, 2 milliamps, yeah, there it is, 10 microamps. So the 2 milliamp range works. So let's wind the wick up on my Keithley current source. No, that's not budging. No, there's something, that's supposed to be like 100 milliamps. No, there's something wrong with that. But that's pretty cool that that puppy still works. So let's see what happens if we try and take these boards out. Actually, there's another shot of the contacts down in there, and they've got numbers on them, which is rather quite neat. And you can see those, there doesn't seem to be much, if any, wear on these contacts at all. Very, very nice. But, you know, it's almost as if, like, these have been bodged on as like a, you know, an afterthought or something like that, because that, you know, because that range switch construction is actually rather quite nice. We might get lucky. The range switch looks like it's just going to pull straight off. The screen, the LED display is coming out, so I better, oh no, hang on, yeah, sorry, not keeping that on camera, I'm too busy worrying. There we go, look at that. There's our range switch down in there. There it is. I better like leave it in the correct position, but nice balls in there. I love a multimeter with a good set of balls. Interestingly, that red Perspex window is not held in with anything. It just sits there. Well, if it did have some glue on it, it's worn off with age. And there we go. We have our LED display and the top of the board. Look at that. Intercell chips. Check them out. There we go. Look at that. Well, there, right, the LD11. And there's our 555 timer. Beautiful. Yeah. Confirmed our manufacturing date, 20th week 1980, 25th week 1980. Fantastic 4511 LED display driver. Oh, look at that. We've got ourselves a, looks like what was supposed to go to a shield, and you can see the mark. It is. Is that got that shield in? Look at that. They've actually exposed that. And that is like a nickel shield or something like that. Yeah, there we go. That's for real, folks. Excellent. Shielded front cover. Brilliant. Now, as for the input sockets, they've actually manufactured that as a complete assembly. Look at that. Screwed it down to the board. Not bad at all. They've even put the identifying marks on the PCB. Nice attention to detail. Excellent. There's some, you know, wiring attached directly to that. I mean, check that out. Big, beefy wiring going, well, somewhere. Does it actually snake under there? And is that the one that pops out? No, they've got that going to there. That looks like, it almost, no, I thought it was. I thought that was like a little bit of coax. Sorry, got it off camera there. Thought there was a bit of coax going across there, but it's not. And, oh, look, we have ourselves, is that a, no, I thought it was like a thermistor, but it looks like it's a tantalum that they've just bent over on the board. Look at that. Oh, that's hilarious. So that looks like a 16 mic tantalum, 35 volts. The old dipped tantalum types, and they are notoriously unreliable. They're horrible little beasts. There's a few of them in here. Looks like there's a couple over there as well. They are, yeah, absolutely horrible little things, and I'm surprised that it still works, but look at that sucker. Wow, look at that. We have our, that's our transformer. That's our DC to DC converter transformer that we saw on the schematic before. That's been driven by BFJ 64 transistors there. Massive can package, look at that. But this is like really home-built stuff. Then we've got some, you know, traditional carbons there with sort of like just, you know, the brush painted on type. They would have just had they spun the resistors on there and just painted that, painted those color code rings on, and then lacquered them. And oh man, it's just classic. I love it. Look at that, really old school stuff. Unbelievable. I mean, you know, it's not a thing of beauty really. It's pretty darn horrible. And just below our sockets there, there's our big beefy 10 meg input resistors down there. Absolutely massive. That's our LED display. Standard pinout. I love the tape the taped artwork there, just going, connecting those displays up. Oh, brilliant. That brings back lots of memories. Let me tell you, individual digit driver transistors there in your classic plastic package there, instead of, you know, these, I don't know why they got these metal can packages down there. You know, they're obviously power transistors. And there's our function switch there. Look at that, you know, all sort of, all custom made PCB contacts down in there. And the boards joined together. I mean, I'm not going to take these boards apart. I don't think it's worth it. I'm sorry, but I really, you know, I really like this little multimeter. It's classic, and I'd hate to have to just desolder everything and rip the damn thing apart. I don't think it's worth it. I don't know. Maybe I'll run a poll on the forum. Who wants me to strip the thing down and really, you know, I can't see a huge benefit in that, because we can see, you know, most of the hideous construction in this thing. But I guess it wasn't too unusual for its day. I mean, you know, actually, let's do an interesting comparison to my old SAW ME533 digital multimeter. This is the first digital multimeter I ever got. It was a hand-me-down when I got it, and yeah, it served me well for many, many years. Unfortunately, the screen is cracked now, and I do remember, but I cannot find this. I'm going to have to go through my old collection of Electronics Australia magazines, but I've talked about this before. This was the multimeter that was used, I believe, the same one that was used in a Fluke ad of the time, advertising the Fluke 70 series, and the slogan was, how to beat the high price of cheap multimeters. And this was like, it was beat up and it had tape all over it and all sorts of stuff. So this was the cheap multimeter that Fluke were comparing it to. And yeah, I remember seeing that ad and going, oh, almost crying, because, well, this was my pride and joy back in the day. I'm not sure of the age of this. Let's open and find it out. I mean, there's not much in there. This is basically a single chip. I do remember taking it out. It's like a single chip solution that does everything, but, you know, really old school, you know, end-on resistors there. They've just used like an off-the-shelf rotary switch there, you know, pretty crusty. Oh, look, we have some MOV input protection. Wow, stunning. But yeah, put some tape around there to pull the fuses out. Obviously some battery leakage there, but let's that's, you know, this is like a big contrast in terms of you know, the system integration in the single chip multimeter. But I think this is not too dissimilar age. So let's see if I can pop that off and have a look at the chip, get a date. Here we go. I got the sucker off. It looks like I had put some tape on there, because yeah, I kind of remember that. That's I put some like plumber's tape on there, I think, because the shaft of that, it was just one of those fluted shafts, and my knob fell off, and I fixed it. Oh, ta-da! There we go. Look at that. Ugh. But yeah, I mean, you know, streets ahead in terms of integration and technology and construction and everything like that. By the way, this one had the unique ability to do low ohms measurement as well, so it wouldn't turn on a diode junction. Really quite neat for its time. And there it is. There's my poor old SAW multimeter. What's the date on that chip? 9773. Well, I can guarantee you that's not a date code, because this thing wasn't manufactured in 1997 nor 73. Brings back so many memories, so many measurements. And that's actually rather neat how they've mounted that LED display board there on that angle. They've just sort of done a cutout in that PCB there, just wide, and it looks like they've beveled it just wide enough for that board to slip in at a certain angle. And if we have a look under the display board here, I took off the 2 screws on top there. Ta-da! There's our other chip, and look, it's mounted in those freestanding machine pinned sockets. Look at that. Oh man, it just it gets bodgier every time you look at this thing. Unbelievable. So that's the LD 111 down in there with the LD 110 on the top. But Oh, man. So there you have it. I think we'll call it quits on this Yugoslavian multimeter. But look at that. Have you ever seen multimeter construction like that? That is great. Oh, man. Unbelievable. Anyway, thank you very much, Sylvain, for sending that in, because that is terrific stuff. And it's a Digimer 10 Iskra multimeter. Now you know. Bit of pub trivia there. Name a 1980s vintage Yugoslavian multimeter. Ah, that's easy. It's an Iskra. And that is cheapo retro multimeter porn at its finest. I love it. If you want to discuss it, as there are many vintage multimeter aficionados on the EEVblog forum, that is the best place to do it. The link to individual forum threads for each video is down below. That's down there if you're on YouTube, maybe up there if you're watching on the blog website, if you watch the embedded video. If you're watching the podcast version, well, you can't link it anywhere. Tough luck, you have to just type it in manually. And yes, I'll scan the schematic for this thing so you can take a look. If you like Teardown Tuesday, please give it a big thumbs up. 1 thumb up, 2 thumbs up, I don't care. Or if you don't like it, you can give it a thumbs down. Whatever. Catch you next time.